Hi guys, today we'll be discussing the LLD of an app like Uber or Ola. First we are going to be discussing the design on whiteboard. Then we are going to convert our design into code and we are going to make it up and see that okay what happens. This is obviously going to be super interesting and I really hope you find it helpful. But without wasting any further time, let's get started. So what are the important components in an app like Uber or Ola? Obviously there is going to be a rider who is going to be booking a trip or a ride. Right? So there is rider and there are also a bunch of drivers or cabs. So in today's design, we are going to assume that every driver has one cab and every cab has one driver, and we are going to be using the terms interchangeably. So basically I'll be using driver. You can just assume that I'm talking about a cab with a driver. Obviously we are going to be designing Uber in an hour, so we have to make some assumptions. So this is one of the first assumptions that we are going to make. And the most important feature that we are going to be designing today is obviously creation of a trip or a ride. So basically there is a rider, any particular rider who is going to call that, okay, create a trip or a ride. So our rider will be saying that, okay, I am at this source location, I have to go on this destination location, create a trip for me. That is all the information that Uber or Ola has. Now we have to do the rest. Let's just start thinking about the steps that we would have to follow when we are creating a trip. First thing first, we have a rider over here. We have a source location and a destination location, but we do not have a driver yet. So the first thing that we're supposed to do is driver matching. So basically we need to see that who is the driver who is going to fulfill this particular trip request. So we are going to match the appropriate driver. Now this could be based on a lot of conditions. One very simple condition is just get the nearest drivers and send requests to them. The first one who accepts it is going to fulfill this particular trip request. Or maybe we want to assign a driver with a very high rating. Or maybe we want to assign a driver who hasn't fulfilled a lot of trips in last 24 hours. Or maybe a combination of these conditions, and we have to find an optimal way of finding the appropriate driver for this particular trip. So the first thing that we have to do is driver matching. Now after we have a driver, what do we have? We have rider, we have driver, we have source location, we have destination location. The next thing that we have to do to start the trip is basically pricing. So we have to see that this particular trip should be of how much price. Now again, this can be based on a lot of conditions. Maybe it is based on driver's rating. Maybe if the driver's rating is a lot, maybe you want to charge more. Or maybe it is on rider's rating, that if the rider's rating is very good, you want to charge a premium customer less. Or maybe you have a very default pricing that, okay, per kilometer, this is going to be the fare. Or maybe again, it is a combination of all of these conditions and we have to find the optimal price or fare for this particular trip. So these are the two important things that we are going to be doing in order to create a trip. Before getting into the details of how we are going to be doing the driver matching and the pricing, let's first discuss how we are going to deal with our riders and drivers. Now there are a bunch of users or riders who have obviously registered on our app Uber or Ola, so we need to manage them. So obviously there has to be a class who takes care of all the riders. So let's say I call the class as rider manager. So basically there is one particular manager, and what is the responsibility of this class? The responsibility of this class is to take care of all the riders, store information of all the riders. We can probably have an unordered map that for this rider ID, this is the rider that we have and all the information of the particular rider. Also on the whiteboard, I'm going to be drawing the conceptual class diagram, but I have drawn a proper specified UML class diagram online. I took a lot of time to draw that. And I'm going to show you that when we are going to write code and we are going to convert that into code properly. But right now this is conceptual design. So we have a rider manager who is going to take care of all the riders. Now one thing that I hope you are probably already thinking of, I obviously want only one rider manager to take care of all my riders. I want only one instance. So I hope you are thinking about it right now. Obviously, we are going to be using singleton design pattern over here because I want only one instance of the manager who is going to take care of all my riders. So we don't have to worry that, okay, different instances for different riders. So we don't have to worry about different managers for different riders. Here we are going to have only one manager for all the riders. Maybe if the number of riders increase, we can do sharding and all, but that comes into HLD. Right now we are talking about LLD and there's going to be one instance of rider manager who's going to take care of all the riders. Similarly, I need to take care of all my drivers. So again, I'm going to have a driver manager. This will also be a singleton class and this is going to take care of all the drivers. So till now we have two classes, rider manager, which has a map of all the riders corresponding to rider ID. It is going to store all the information of rider. So there obviously has to be a class for rider, which is going to store all the details of a particular rider, like whatever we need, like KYC, DOB, all of that. So we're going to store all of that information in this particular class. Then again, there has to be a class driver. So in driver manager also there is going to be a map corresponding to driver ID, store this driver, and driver is also going to have a lot of details, and in our case it is also going to have like cab details because our driver has one cab, so maybe cab details, and maybe also the availability of driver. So when we are going to be doing driver matching, maybe we can check that, okay, is the driver available or not? Because obviously if driver is not available, then we don't send request. So we can have the availability boolean also over here so that we can check that, okay, this driver is available at this particular time or not. And obviously every driver can update that, okay, I'm not available right now or I'm available right now. So that is going to be taken care of over here. Now, what is the relationship between rider manager and rider, and driver manager and driver? This is where we realize the importance of UML class diagram video, because there we have discussed all the relations between the classes properly. And if you have not watched that yet, go watch it because it is very, very important. It is going to help you understand the relationships between the classes. But right now, even if you have not watched it, it's fine because we are going to discuss this particular relationship. So basically, rider manager has information of all the riders. So basically, rider manager has an instance of rider. Driver manager has an instance of driver. So it is going to be either aggregation or composition. But over here, rider can exist separately. So it is not like only when we create the manager, rider is going to get created. There is already a rider, there are drivers, there are cabs. That is how we are designing a system. Maybe your interviewer tells you or your requirement says that is not the case. You create a rider or driver only if driver manager, rider manager is there. In that case, it will be composition. But right now, our riders and drivers are going to exist independently. So there are going to be riders and drivers. Our rider manager is going to add them and our driver manager is going to add drivers. So basically, this is going to be an aggregation relationship. Basically, rider manager has an instance of rider, but riders can exist without rider manager also. So that is the aggregation. Over here also aggregation relationship because drivers can exist without driver manager, but driver manager has an instance of driver. I'm saying it again, if your requirement says that your riders and drivers can't exist without their managers, then it will be composition. Right now it is aggregation. So we know how we are taking care of our riders and drivers. There's a rider manager in aggregation relationship with rider class, driver manager in aggregation relationship with driver. Now obviously the most important class is going to be a trip class. Now there is another point for discussion with your interviewer or with any person who is giving you requirements, that when is the trip created? Now there can be cases that a request from driver came that this is my source location, this is my destination location, create a trip for me, get me a driver. But maybe there was no driver available, maybe the weather condition was bad or anything, no matching happened. In that case, is a trip created or not? These are the little questions that you should really think about while doing the low-level design. Right now in our system while designing, I'm assuming that the trip is created only after a driver is matched. So if there's a request and a driver couldn't be matched, it is not going to be called a trip. But you could choose to design it like that trip is still created, but there's a trip status that says that driver not found. Maybe that is one way to go about it. In that case, it is possible that inside this trip, the driver is going to be null. Basically, there is no driver assigned. But right now, I'm assuming that driver matching would have happened when I create a trip. So there will be a rider, there will be a driver, there is going to be source location, destination location, price, all of the details are going to be stored in this one class, the most important class, trip. So we know that this class trip is going to store all the information of a particular trip, like driver, rider, the trip status, what is the price, obviously there is going to be trip ID and all the information. So that is done. But now comes the most interesting part. How are we going to determine that, okay, who is going to be the driver for this trip and how are we going to determine the price? So this is the most interesting part of the video. First thing we have to do is driver matching. And the second thing that we have to do is decide the pricing. So these two things we have to determine, and we discussed that these depend on a bunch of conditions like weather, rating of rider, driver. There can be a bunch of conditions. And actually sometimes we might want to use a particular algo, like suppose there are a lot of drivers and I can afford that I want the highest rated driver. But sometimes it might happen that because there are so less drivers in a particular area because of weather conditions, I just want the nearest driver. Similarly about pricing, in some areas we might want a default price. In some areas, we might want price on the basis of maybe rider rating, driver rating. So we have a bunch of algorithms that we should be able to support. And yes, if you know design patterns, you must be thinking in the right direction. But if you don't know that, that is also fine because you're going to learn a new design pattern today. So here we have to support a bunch of algorithms. Basically, there are a bunch of strategies to do driver matching or to determine the pricing. So here we are going to be using strategy design pattern. If you don't know it, don't get overwhelmed because we are going to break it down very properly. Even if you're a beginner, you will be able to understand. So just stay tuned. In very simple terms, there is going to be a particular algorithm which is going to help us decide that, okay, how are we doing the pricing and how are we doing the driver matching. So this algorithm, every way of doing this, every algo is going to be called a strategy. So there are different strategies on the basis of which you can do the pricing or you can do the driver matching. So basically we have a pricing strategy and we have a driver matching strategy. Now there can be a bunch of pricing strategies. Suppose there is one default pricing strategy, or it can be say a rating based pricing strategy. So you could be doing your pricing, maybe a default pricing like per kilometer, this is the price. Or maybe on the basis of rating, you're deciding that this is going to be my price now. So there is rating based pricing strategy. Obviously, as we had discussed earlier, there can be a lot of pricing strategies possible. Here we have taken two examples, default pricing and rating based. Similarly, for driver matching also, there are a bunch of strategies that are possible. Say one is like least time taken driver matching strategy. So DM strategy, I'm just saying. So these are different strategies. So now what I'm going to do is I'm going to actually create classes of all of these. So pricing strategy is a class, driver matching strategy is a class, least time taken driver matching strategy is a class, default pricing strategy is a class, rating based pricing strategy is a class. Now let's discuss the responsibility of each of these classes and we will understand exactly what they are doing, right? So these pricing strategy classes are doing what? They basically have the algo on the basis of which we are deciding the price. So basically there is going to be a function called say calculate price in these two classes that is going to determine the price of a particular trip. So we are going to pass a bunch of information on the basis of which it will see that, okay, what is the price? So in the rating based pricing strategy, what it will do, it will see that, okay, if this is the rating, this should be the price. If this is the rating, this should be the price. Similarly, this strategy will do what? It will say that, okay, this is the location, so per kilometer price should be this. So the responsibility of these classes is that calculate the price based on the algo that you're supposed to support. Similarly, over here, for this least time taken, there will be a particular algo on the basis of which we are going to be doing. Right here, we are supposed we have a function match driver. So here, this class is going to have the logic. It is going to have the algorithm on the basis of which we are going to match the driver. So the responsibility of matching the driver is going to go to this particular class, and the responsibility of calculating the price or based on a particular algorithm goes to these classes. I have written this a bit more properly. So the responsibility of these classes is that run the algo and determine the price or the driver. So allocate the price or allocate the driver who is going to be allocated to the trip. And as you must have guessed by now, so the calculate price function is going to be there in this pricing strategy, and these classes are going to implement it. So basically, it's okay if you're not understanding, it will get clear. You're going to see the code also, you're going to see more of the diagram. It will be clear, just be with me. So these two classes are interfaces and they have functions what? So this class is going to have function match driver, and least time based PM strategy is going to do what? It is going to implement that function. Similarly, pricing strategy is an interface and these two classes are going to implement that function calculate price. What happens when we have interfaces? So basically we are making sure that every strategy that is being inherited from pricing strategy has to implement the function calculate price, and every strategy that is inheriting from driver matching strategy has to implement the match driver function. So how is this code extendable? Tomorrow if there's one more strategy, say we have right now only one strategy, say we have another strategy tomorrow, we can just add it. So we will have only one more strategy that is going to implement pricing strategy or driver matching strategy. So this is very, very extendable, that any number of strategies can be supported. And when we have to support a new strategy, all we have to do is inherit from pricing strategy and basically implement the function calculate price or match driver. In the UML video where we discussed the class relationships, we understood that when we are implementing an interface, so basically interface, if you see in the specified UML that I'm going to show, the name is going to be written in italics and under these closed tags. And here these classes are implementing these interfaces. So that is why this arrow and dotted line, that means it is implementing and these are interfaces. So now we have a bunch of strategies or algorithms to decide the pricing and how we are going to do the driver matching. But now someone should be responsible to decide that right now which strategy I'm going to use. So there are a bunch of options, but I need to choose one strategy right now, right? So who's going to do that? So for that, I'm going to assign like one class whose entire responsibility is this, and I'm going to call it strategy manager. So the responsibility of this class is what? It is managing the strategy. It is deciding that for this particular trip, this is the strategy that I wanted to use for pricing and for driver matching. If it is not clear, just stay with me. So our strategy manager should obviously be able to call the driver matching strategy and the pricing strategy, which are basically interfaces, but strategy manager should be able to call them. So what is this relationship again? This is association and it is unidirectional association. Why is this unidirectional? Because obviously pricing strategy and driver matching strategy should not be able to access the strategy manager, but strategy manager should be able to access these strategies and tell that, okay, this is the strategy that you should be using right now. Quick recap. What are the responsibilities of these classes? They are implementing the algorithm or the strategy or the way in which the pricing is going to be determined or matching is going to happen. These are interfaces based on which we can implement different strategies. There is this class strategy manager whose responsibility is to decide that what strategy are we going to use for pricing and for driver matching. Now obviously the strategy manager is going to make the decision of choosing a strategy on the basis of some data, right? So it needs some data to decide that, okay, this is the strategy that you should be using. Now that data can also vary and it could also change over time. Like right now, maybe I just need ratings and maybe locations. Tomorrow, maybe I need some more data, like weather conditions. Right now, maybe I don't support weather conditions, but tomorrow I support weather conditions. So I don't want to send entire trip details to the strategy manager, because sending entire trip details will mean what? See, trip will have what? It will have rider, it will have driver. So all the information of the riders, so basically KYC, DOB, everything that we have stored within rider and everything that we have stored within driver. I don't want to send all of that to this strategy manager, right? Strategy manager's responsibility is what? It is to decide the strategy. So there has to be only some data that it needs to decide that, okay, this is the strategy that we are going to follow. So for that, we have taken another class, basically that will be called trip metadata. So this is just the name that I gave. You could actually call it anything. But right now I'm going to call it trip metadata. So what this class is storing? Basically this has some information of the trip which will determine that, okay, which strategy should be used. So this doesn't have the entire details of the trip. It only has the information that a strategy manager is going to require to decide that, okay, what is the driver matching strategy that we are supporting, or what is the pricing strategy that we are having for this particular trip. So obviously our strategy manager class should be able to call or access the trip metadata class. So this is what? This is unidirectional association, because trip metadata cannot call strategy manager, but strategy manager can call trip metadata. Now two quick points over here. First thing, right now I'm assuming that all of the information that is required by the strategy manager to determine both the strategies is in this one class. You can also do two different classes, one to store the information to determine the driver matching strategy, one to store the information to determine the pricing strategy. That is one way to go about it. But almost all the factors that I had in mind while deciding the strategies were common, like weather conditions, like source location, destination location, ratings. So I thought that it is better to have only one class to store all the information that strategy manager is going to require. But maybe we can have two classes, one to store the information that is going to require to determine the driver matching strategy, and one to store the information that is going to be required to determine the pricing strategy. And both can be accessed by strategy manager. So you can do another level of layering over there, but right now I'm keeping it in one class. Second point to note over here is that I'm again and again saying that both the strategies are per trip. are you thinking about it that why is it per trip? I was actually a bit confused initially, but I actually thought about it. So every trip request that is going to come, now sometimes it will be for different locations. Now if you are in a metro city, maybe you want to follow another strategy. If you are in a tier 2, tier 3 city, maybe you follow a different strategy. So maybe the strategy depends again on a lot of factors, but it is going to vary per trip, right? So it is not like all the trips in a particular city can or will have like one strategy. Maybe that is also going to vary. So in order to keep it very simple, what I've done is, in the trip class itself, there are going to be two more attributes, the pricing strategy and driver matching strategy. I'm not making it because the diagram is going to become very hodgepodge, but basically these two, whatever pricing strategy we choose, whatever driver matching strategy we choose, we are going to store them as attributes in the trip class, just like rider, driver, trip status, all of that. So we know that for this trip, this was the strategy that was being used, or that is the strategy that is being used. Now comes the final stitching point of the video, that how is the trip being created? Who is actually doing that? If a request is coming, create trip by say the main of our code, where is that request going? So I guess most of you have already guessed that, okay, there is going to be a trip manager. And all the trips are going to be managed by this trip manager. Just like all the riders are being managed by this rider manager, drivers by this driver manager, all the trips and trip metadata is going to be managed by this trip manager. And that is why I moved my trip class from here to here to draw the relationship. Now an interesting point over here. What is the relationship between trip manager and trip? Here there was aggregation relationship, right? But I am saying that over here it is going to be a composition relationship. And as we make more and more classes, you should start thinking that, okay, why so, why this? Because there can be no trip created if there is no trip manager. So trip manager is the one who is responsible for the existence of the trip. Trip is a part of trip manager. Trip metadata is a part of trip manager. So that is why this is composition relationship. Trip or trip metadata cannot exist without trip manager. We are creating the trip only in trip manager. Who is doing the creation? Trip manager. So the existence is dependent on that. That is why composition relationship. So our create trip request is going to go to this trip manager. What is the first thing it will do? It will go to the strategy manager and tell that, okay, based on this metadata, determine that what strategies are going to be used, and then it will create a trip. So obviously it should have access to the rider manager and driver manager. So there has to be a relationship like this also. Now what relationship will be between trip manager and rider manager, driver manager? Think about it. It will again be an aggregation relationship. So basically trip manager has an instance of rider manager or driver manager, but rider manager and driver manager can exist without trip manager. Now why can they exist without trip manager? Let's think like this. Now we have just created our system and there are no trips right now. But we obviously are trying to have some users on board, have some drivers on board. So there are some riders and drivers who have registered, but they have not created any trips. So there is no point of having trip manager till then, right? So in that case, what I want to do, I want to have the rider manager, driver manager. Now you could be choosing to create your trip manager in the beginning itself and then create rider manager, driver manager. But that is again a very thin line between aggregation and composition that we had again discussed in the UML class diagram video. But in very simple terms, if you decide that, okay, riders and drivers can exist without trip manager, it is going to be aggregation relationship. But if you make a design choice that no, I want my rider manager, driver manager to be created only after trip manager is created, and I'm going to create my trip manager in the beginning of the system itself, then yes, it will be a composition relationship. But for now, I am keeping it an aggregation relationship. Now another point to note over here, as I mentioned earlier, the rider manager, the driver manager class was singleton. Similarly, I have made the strategy manager and trip manager classes also as singleton. Basically, all the managers, I just want one instance of them to manage everything. I want only one instance of trip manager to take care of all the trips. Just like rider manager had like map of riders and driver manager had map of drivers, trip manager is going to have a map of trips and trip metadata. You will see the detailed UML diagram and the code, so just bear with me. But for now, I hope you can understand that I want only one instance to take care of all the trips of all the trip metadata. I think we are ready to dive into the code. Just one quick thing to discuss before we do that. Some of you might think that we have not covered the creation of the cab part, like cab could be share, go, premier, like that, right? That seems to be a very typical case of factory design pattern. Just how we create vehicles in vehicle factory, we could be doing that. Obviously, I have to decide a set of requirements for which I will be designing, and I chose to not cover that. But obviously, I can cover that in the rest of the videos. Right now, we are going to cover the code of all of this, and I hope you are finding it helpful. If you are, before we dive into the code, just take 2 seconds of your time to share the video with someone, and you have no idea how much that will mean to me. You can't imagine the amount of thought and the amount of effort I have put into the design and the code. When you see the UML diagram, I used to hate making UML diagrams in daily work, but I did that with all the details because I want everything to be perfect. I'm going to be uploading the code on GitHub as well as the UML diagram for reference, and I'm going to take all your feedback and I'm going to create the entire LLD series, cover all the topics that you want me to cover. So just take 2 minutes of your time and just share the video with your friends. Just subscribe, it will mean so much to me. Let's get to the code now. So this is the UML diagram of the design that we just discussed. I am so proud of the effort that I've put in this. I made all the arrows and I made all the specifications proper in this. So yeah, so we started our design from over here. If you remember, we started discussing that since we have to deal with our riders and drivers, we kept a rider manager for all the riders and driver manager for all the drivers. So if you remember, I had said that we can keep a map of the ID and the riders. So over here, I'm taking the name itself as ID to keep it very simple. Otherwise, obviously, there will be an ID generated, and there is the map. And I had said that rider manager is going to be static, so the instance is private. And I had said that the rider manager is going to be singleton, so the instance is a static. Underline means a static if you have watched the UML class diagram video. And I have also made the getter as a static so that I don't have to create object and I can just get the instance without creating the object. And then I have functions like add rider, get rider in this map. Then obviously there's rider class. Right now I'm just keeping basic stuff like rating and string. Obviously there'll be a lot more details. And similarly for driver, in driver I have just added the availability ka boolean also, which I've actually not used anywhere, but it can be used in one of the strategies. So I've just added it. And there's driver's map just like rider's map. So this much is done. Now let's get to the interesting part. So this is the strategy manager. It can call pricing strategy and driver matching strategy, which are interfaces. So you can see that these are in italics and the tags. That means it is interface. So these are the strategies that are implementing. So this is the dotted line. What is the function that they're implementing? Over here, calculate price. So we are passing what? We are passing the metadata. So what is metadata? Metadata is actually this information that is going to be passed over here. So I have not showed the relationship between metadata with these because obviously it will become too hodgepodge, but I guess these little things are obvious now. So this strip metadata will be used by these strategy classes to actually run the algorithm all this strategy. So what are the different strategies right now? There is default pricing and there is rating based and there is least time based matching strategy also. And over here there is obviously match driver. Over here it is calculate price. In the strategy manager, again, since this is singleton, so this is static and getter is also static so that I don't have to create an object. And what are the two functions it has? Determine the pricing strategy, basically what will be the pricing strategy that we will use, and determine the matching strategy. What is the information that we need to determine the strategies? It is just the metadata. So let's look at the metadata also. So in metadata, I am passing rider rating, driver rating, and the source location, destination location. See the difference between trip and trip metadata. In the trip, there is a lot of details. Like there is the entire rider and the driver object, but I don't need the entire object. I just need some information like the ratings or maybe some other information also, which I can pass later. But the point is, a strategy manager should not have access to all the trip data. That is why this trip metadata is there. It is used only to determine the strategies and to run the algorithm or to run the strategy and calculate the price and match the driver. So here in the trip, what else is there other than the rider driver? There's source location, destination location, the trip status, the ID, then there's price, then also there are the strategies. So both the strategies will be part of trip. We had discussed why these are part of trip because the strategy is going to be decided per trip. So we have stored it within the trip itself. Then there's just the constructor. We are displaying the trip details and there's a getter. Metadata is understood. Now the last part, basically the stitching point over here, is the trip manager. So we had discussed the various relationships of trip manager with all the classes. So it has rider manager and driver manager, but we had discussed that this is aggregation. So you can see over here, and you can see that it has rider manager and driver manager. It is just that it can be created outside also. So it is there for aggregation. Similarly, it has the map where all the trips and trip metadata is stored. The creation is happening over here only, create trip. So what is the point where creation is happening? It is over here. So what are the things that we pass? That for this rider from this source location to this destination location, create a trip. Now inside this trip, whatever will happen, we will see in the code. So again, this is also singleton. So this is static. There is a mutex and there is a getter, which is again static. And this has rider manager, driver manager that we already discussed. There is metadata info and trips info, basically maps which have ID and then trip ka information and metadata ka information. So I hope you have understood the UML diagram at least. Let's start looking at the code now. Let's start looking at the code from where we started designing also. We started from rider manager and we made it singleton. So here the constructor is private and there is only one instance which I've made static, and there is mutex, and there is one getter. So the instance is going to be returned over here, and every time this getter is called, this one instance is going to be returned. If you have doubt in singleton design pattern about the implementation, then there is an entire video on singleton design pattern. Go watch it after watching this video. And I've also covered it in detail in the Zerodha LLD video also. It is very, very important. It will be used in almost every LLD design. So please do go check it out. Singleton is like very, very important design pattern. Okay. And other than that, we have a riders map. So basically corresponding to ID, riders we are storing, and then there is add rider and get rider. And let's look at the CPP of this HPP. So here's the CPP for the static members I've just initialized over here in the getter. So here we are doing what? We are doing double check locking. So we need to lock to make it thread safe, that okay, if the instance is null, then we have to create, otherwise we don't have to create. And while creating, we have to put a lock so that multiple threads don't access it. But since the lock is expensive, what are we doing? We are putting another check that only the first time put the lock, but the next time we know that it is not null, then again and again why to put lock. So this is called double check locking. Then we are adding the rider to the map, and then we are getting the rider also. So this is rider manager. Similarly, there is driver manager. So the HPP is very similar. And again, so this is also singleton. So the constructor is private. And again, there is an instance that will be returned by get driver manager, and there is driver's map. Very similar stuff. Let's look at the CPP also. Again, similarly, the static members and the getter is very similar. Double check locking is there. Then we have add driver, get driver, and then there is unordered map that we are returning. So there's a getter for the map also. Why is this? We will see it in the code later. So we have seen the rider manager and the driver manager. Now let's start looking at a strategy. So over here, there is a strategy manager. So what is the role of this class? It is going to determine that what is going to be the pricing strategy and what is going to be the matching strategy. So if you see, we are just passing the metadata over here. Let's quickly look at our metadata also. So this is what our metadata has. It has source location, destination location, and the rating. So it doesn't have the entire driver and the rider ka objects. It has just the rating. And tomorrow, if you want to pass more things to the strategy manager, or for to run the strategy, we can actually pass it in this metadata itself. So we don't need to change the code a lot, and this is extendable. And then there is getter of the rating over here, and there is setter. So yeah. And one interesting thing to note over here, in the trip ka metadata, what are the things that we are passing in the constructor? It is source location, destination location, and the rider rating. Why is that? See, we will start looking at from where the creation of the trip is going to happen. Just note that when we send the request that create the trip, we have only three information: source location, destination location, and rider. We do not have driver yet. And that is why there is a setter of the driver. We'll discuss all of this. We will see the flow, how the creation is happening. Right now, just see that what are the attributes and what are the functions that are supported in each of the classes. Coming back to our strategy. So this is again singleton. So private constructor. Again, there is an instance and there is getter. Now let's look at the CPP. Again, these are static and double check locking. So basically all the managers we have made singleton: strategy manager, trip manager, rider manager, driver manager. Similar code, all of them singleton. Okay. Now determine pricing strategy. Right now I have just done what? I have just put an output statement, and I have done that create new rating based pricing strategy. I will actually run the code and show you that how the price will differ when we use different strategy. So when is the pricing strategy and the matching strategy being created? It is being created over here. So this is the one that is responsible for creating the strategies. So what was the responsibility of the strategy manager? To determine what pricing strategy to use, and it is creating that pricing strategy or that matching strategy and returning. See, strategy manager is the only place where we will come to know that, okay, what all strategies are there. So tomorrow if new strategies are going to come, only strategy manager need to know that, okay, new strategies have come. Because everywhere else we are just going to pass the interfaces, the pricing strategy and the driver matching strategy. We are not going to pass that what all strategies are there. This manager is the only class that is going to know that in detail these are the strategies. So how is this extendable? Tomorrow new strategies come, I just have to add over here. That is it. So this is the only place where we know all the pricing strategies and the matching strategies that are there. Now let's look at these interfaces, pricing strategy and driver matching strategy. Let's have a look at the pricing strategy first. So here you can see that I have made it abstract, how I have done virtual and I have done equal to 0. That basically in C++ makes it an interface. So now all the classes that inherit from pricing strategy have to implement this particular function, have to calculate the price and return the price using this metadata. Okay, so we are passing the data and you have to calculate the price on the basis of that and return the price value. Now let's see what are the pricing strategies that I have implemented. First one is this rating based pricing strategy. So this I have made it very simple right now. I have said that calculate price based on this metadata. So now metadata also has the rider ka rating. So I am saying that if it is high rating, then charge less. Basically, put the price as 55, otherwise put it as 65. This is just for demo purposes, and I have put an output statement and I'm returning the price. So here you can see that only if it is 4 stars or 5 stars, I'm saying that it is high rating. So basically if it is going to be 4 star, 5 star, I'm going to give 55, otherwise I'm going to give 65. So you're going to see this when I run the code, that if the rating is 4 or 5, then the price is 55, otherwise it is 65. So this was one pricing strategy. The other one that I have implemented is default pricing strategy. So here I have just put the price as 100 and I have returned 100. That is it. Just some simple. So I'm assuming that all the trips are going to be 100. So this is just for demo purposes. So we have seen pricing strategy. We saw that this is the interface and we saw that 2 classes implemented this interface. Similarly, there is driver matching strategy. Now this is also interface and 2 classes are going to implement it. So let's get inside. Again, I made this abstract, how virtual and equal to 0. So all the classes that inherit from here, I have to implement the function match driver, and it is going to match the driver and it is going to return the driver that is matched, and it is using this metadata. So let's look at this. Now I've implemented only one matching strategy for the demo purposes, and that is called least time based matching strategy. So here you can see that in order to match, now one more relationship. You remember in the driver manager I had put a getter of drivers map. Why I put that? It's very simple to understand. Basically here I am matching drivers, so I need access to all the drivers. So I need to access driver manager over here. It is very easy, right? To access the drivers in the matching strategy, I need driver manager. So it has access to driver manager. So this relationship I have not shown in the diagram because again the diagram would have become very hodgepodge, but you can understand. Here I have just checked that at least there is one driver, and for demo purposes I have returned the first driver always. So in the drivers map, whatever is the first driver, I am setting that as driver. So I have not implemented anything over here. I am just returning one driver. This is just for demo purposes. So we saw the rider manager code, we saw the driver manager code, we saw the strategy manager code, and we saw the 2 strategies, the interfaces, and what all is implemented. Let's finally look at our trip metadata and trip manager. So trip is the main class. As you can see, it has all the details: rider, driver, location, trip status, ID, price, and the strategies. Again, the strategies are per trip, so that is why they are inside this. There is a normal constructor where I'm generating trip ID just to display it, and this is not thread safe. I have just taken a static variable and I'm incrementing the value in constructor every time, and this is just a getter, and I'm displaying all the trip details. Let's look at our main stitching point again, the trip manager. Since this is going to be singleton, so these are static. And here see, we have rider manager and driver manager. Since these are variables inside this, in the constructor itself I am getting them. But This is aggregation relationship, not composition. Why? Because you will see that I have created these rider manager and driver manager outside also. I'm not creating it only inside over here. So that is why it is not composition, it is aggregation. See, that is why UML diagram is so helpful. If you would have just looked at the constructor, you could have assumed that, okay, this seems to be a composition relationship. Unless you actually see all the references of get rider manager and you see that it is actually being called from somewhere else. Let me show you also. So this is the uber.cpp class, our main class basically. So over here, if you see, I am creating a rider manager over here. So it is not that trip manager only is creating rider manager. That is why it is not composition relationship, it is aggregation relationship. Now inside trip manager, there is rider manager, driver manager, and there are two maps. One to store all the trips information, one to store all the metadata information. Here we are creating the trip and here we are returning that, okay, all the trips just return that, and then there is just the getter which is returning the single instance. This is the trip manager CPP. This is just getter, just like double check locking for all the singleton classes that we have done earlier. This is where the real magic is happening. The creation of the trip is happening. Now let's see what exactly happens when we call create trip. This is the most important code. Till now, whatever we saw was just implementation of the design. Here is the code. When we say create trip, we have a rider and the rider says that from this source location to this destination location, create a trip and send to me. What does trip manager do? It first creates some metadata that, okay, this is the source location, this is the destination location, this is the rating of the rider. Now, based on this metadata, maybe there's some more metadata that we need to pass. We can do that later. Now, based on this metadata, it gets strategy manager and it tells the strategy manager to decide my pricing strategy and my driver matching strategy. So what is the first thing that the trip manager is doing? First thing, it is creating some metadata because it doesn't want to send all the data to the strategy manager. It creates the strategy manager and it gets the pricing strategy and the driver matching strategy. Once it has both the strategies, what it does, using the strategy, it matches the driver, it has the driver. Using the pricing strategy, it calculates the price and it has the price. So what were the two steps that we had to do while creation of the trip? First thing, match the driver. Second thing, calculate the price. Remember, that was the first thing that we saw when we started seeing the design. That what are the two steps that we need to do? Match the driver and calculate the price. How are we matching the driver? Using this strategy, and this has been created by strategy manager. Again, how are we calculating the price? Using this pricing strategy, and it is being created by strategy manager. Notice here we do not care which strategy it is or which pricing strategy or which driver matching strategy is there. Tomorrow, any new strategy comes, you want to delete any strategy, it doesn't matter, you don't have to change any of this code. Only strategy manager has to take care of determining the strategy and then running the strategy also. We don't have to take care of any of that. Here, we just say that match the driver and give me the driver, calculate the price and give me the price. Here we have already done that. Once we have the driver, once we have the price, we are ready to create the trip. The trip requires what? Rider, driver, source location, destination location, price, pricing strategy, driver matching strategy. All the information we have created the trip. The trip generated a trip ID and we stored all the information in our maps. So basically, trips info was the map to store all the information of the trip. Metadata info map to store all the metadata of every single trip. So this is all that happened. We are going to run the code. Wait, this is getting interesting now. Let's just do a quick recap. In the create trip, first thing, I created some metadata because I don't want my strategy manager to access all the data. I determined the strategies from strategy manager and actually ran the strategy to get the driver and the trip price, and then I created a trip. I updated my maps in the trip manager. Let's look at our main code now, the uber.cpp code. So over here, as you can see, as we had discussed earlier, that before we have to do anything with trip manager, we can be creating riders and drivers, and that is how I designed my system. So here I have created some riders, Keerti, Gaurav, and here I have created some drivers, Yogita and Riti. So they are drivers, we are riders, and now what we are going to do, we are going to create a trip manager. There is going to be only one trip manager instance because it is singleton. And then we are creating a trip for Keerti from this location to this location. Then for Gaurav from this location to this location. and then we are displaying all of this. Let's just quickly see what is the pricing strategy and the driver matching strategy that we had assigned. Driver matching, I have implemented only one, so that is fine. Let us see that in strategy manager, which was the one that I had passed for pricing strategy. So right now I am deciding my price based on the rating that we had seen, that if it is 4 or 5 stars, it should be 55. If it is less rating, then it will be 65. Now let's run the code and see. So this is the output. As you had seen, we were first creating trip for Keerti from this location to this location. So what was the first thing that happened? We set the pricing strategy, then we set the matching strategy. This happened with strategy manager. Then after that we did that, okay, using quad tree, using driver manager, send notification, then sent Yogita as driver based on the 2-star rating. So the rating is what? It is 2 star. Okay, actually we will talk about this also in the code now. Just, wait for this. Let's look at the pricing for now. Based on the 2 stars riders rating, so Yogita's rating I had mentioned as 2 stars. So since it is 2 stars, the trip is 65. The price of the trip is 65. We'll look at this again in the code, so don't worry. But Gaurav's rating was 5 stars, so the price was 55. Okay, and you can see there were 2 trips created. Keerti Yogita 65 and then Gaurav Yogita's 55. Let's look at it now. So here you can see that Keerti's rating was 2 stars. That is why the price was 55, but Gaurav's rating was 5 star. Now suppose I make Keerti's rating as 5 star. Then what should happen? Both the price should be 55 because now both are like good valued customers. So let's run again and see. Here you can see now both ka rating is 55. The 5-star rating that I was talking about, I had said Yogita earlier, but it was because of Keerti's rating. It is because of the rider's rating and not because of the driver's rating that I have done. So yes, this is the output. Now what we will try to do, we will try to change the strategy. Earlier the strategy was based on rating. Now let's try to have a default strategy and let's see what happens. So here you can see it was rating based pricing strategy. Now I'm changing it to default pricing strategy. Now let's see what happens. Let's run it and see. Now you can see based on default strategy, the price is 100 only. And if you see in the trip details, again, the price is 100. So this is because we used the default strategy. So all I had to do, tell the strategy manager that change my strategy. I did not make any change. I just made like one word change. I just changed the strategy over there and everything changed. Now let's look at this quadri wala part that I was talking about. In this LLD video, we did not discuss that how are we doing the driver matching. We discussed that there are a lot of parameters or a lot of ways in which we can do. But there is one way that we discussed in the last video, which was the quad tree video. I'll put the link in the description. So here you can see I've just put an output statement, but here we can use a quad tree to see the nearest cabs. So that is one concept that is used to see the nearest cabs. So if you're in an interview and if you're asked to design Uber or Ola, this is a very important point to mention, that you will use a quad tree to find the nearest cabs. And then because you have access to driver manager, you're getting the details of all the drivers, sending them notifications, then drivers are going to accept, and then one of them is going to be the correct driver. So all of that, this particular strategy is going to take care of, and that is it. So this is finally it for today's video. I really hope you found it helpful. Link to the code, basically the GitHub link, is in the description. You will find the design diagram also over there. And if there is literally any feedback, any constructive feedback, this is when you tell me, please, because I'm planning to make a series out of this. There are going to be many more videos just like this. So if there's any scope of improvement, please tell me. I'm sure there must be so much that I can improve. So please do let me know, and also let me know the topics that you want me to cover in LLD. Like Uber was a very interesting topic to cover. Any other such topics that you have in mind, I would love to cover them. And again, you have no idea how much it would mean to me if you could just subscribe, share with your friends. Thank you so much. Thank you. Bye. See you next time.